Hi, my name is Matt Hendricks. I'm the founder of DSIP Router. So, DSIP Router is a management UI interface for Camilio that actually implements a set of core use cases for a SIP hosting provider. So, that's SIP trunking, that's SIP pass-through, that's also typically is a WebRTC to SIP proxy. So, and a number of other use cases as well. But over the years, we've had to learn how to effectively manage RTP. Part of DSIP Router, we actually ship the RTP engine. In this course, we've taken the time to actually go through the basics of RTP, but also talk about how do you scale out and deploy the RTP engine. So the first thing I'm going to talk through is just the RTP basics. So let's go ahead and get started. So, RTP basics. High level, what is RTP? So, it's really a real-time transport. It carries audio and video payloads across the network from a transmitter to a receiver. This payload is a continuous stream of packets that traverses the network. So, you see in this picture here, what we're depicting is a SIP client and a proxy or media server. In this case, the SIP client will initiate a invite, basically make a call, and inside of it, it will say, "Hey, any audio that's destined for me, send it to this RTP address and this port." Likewise, the proxy or media server will do the same thing. It will actually say, "Hey, in the SIP 200 OK, hey, send me any audio traffic on this RTP address or port number." If you're dealing with typically a Fusion PBX or a Free PBX or just in general a media server, a lot of cases that IP address that you're advertising for audio is the same. But when you start talking about scaling it out, especially if you're a hosting provider or some provider of VoIP services, your bottleneck in your network in a lot of cases is your RTP. So typically you'll have a set of servers that's just dedicated to handling your RTP streams. So let's talk about a little bit more detail. What is RTP? Used in conjunction with a signaling protocol, such as SIP, which stands for Session Initiation Protocol. It typically runs over UDP, and it was developed by the Audio and Video Transport Working Group. It was originally created in 1996. The last update was in 2003. That RFC is 3550. All right, so setting up the RTP stream. So the UAC and the UAS has to tell one another where to send the RTP streams. This is done using Session Description Protocol, which is RFC 8866. The SDP is located in the payload portion of the SIP invite in the SIP 200 OK. So what you see here is what you see depicted here is a SIP invite in a SIP 200 OK message. So in both of those situations, you have a SIP header and then you have the SDP. And we'll get into what that looks like in a few seconds. So, if we dig into this a little bit, let's just talk about, where are the RTP ports? How is that defined? So if we look at the invite portion of it, this is the invite coming from my Zoipier phone. There's a line inside of the SDP, and there's a lot of stuff inside the SDP. We'll get into the details of that in later sections, but for right now, the thing we care about the most is the M equals audio, the A equals RTP map, and the A equals AMTP. And we'll define all those in the next couple of slides here. But for right now, in the M equals audio, this is where it sets up and defines the actual parameters for the audio that's going to be sent in this particular message here. In this case, it's saying that the port number for RTP is 8000. So any audio traffic should be sent to 8000 to my SIP or my Zoipier client. Likewise, for the 200 OK, there's another M equals audio being sent that actually says, "Hey, send it to 19,800." Now, let's kind of break down a little bit more detail of what's inside this STP, especially the three main things we care about, which is the audio, the RTP map, and the format parameter, which is the FMT P. So if you see here, we have this is the 200 OK that came back. We're just breaking it down a little bit more detail. So if you look at the M audio here, the format is the port number, which we looked at just a minute ago. The next thing is the transport protocol, which is going to typically be RTP or secure RTP. And then you're going to have the actual codec format ID. This is important, and the star means you can have multiple of these. So basically, when a SIP invite happens or a SIP 200 OK, it's going to come back with a list of codecs that it supports. So that's what you're seeing here in that first line of the M audio is saying that, hey, 19,800 is the port number, RTP AVP is the transport protocol, and the codecs that support it is 9 and 101. And then also you have the A equals RTP map. So that really maps the codec format ID to the name of the codec. So if we look at the codec format ID of 9, and you look at the RTP map, is basically mapping 9 into the name of G722 with a hertz of 8,000 hertz. And then the last component that we care about is the format parameters. This is the FMTP. Which what this does is specify um, it allows basically parameters of the actual codec to be defined. So one of the ones that was one of the codecs that was specified as 101. 101 is really a telephone event that specifies that DTMF is allowed. And what is showing here in the format parameters is that uh, digit 0 to 15 is supported. And you're like, what's 15 digits? Well, it's 0 to 9, and then you have a star, a pound sign, and a couple other um, um, digits that it supports. So that's what that is representing. But in general, the format parameter line allows you to define a set of parameters for a particular codec. So now that we kind of talked through the kind of the high level concepts of RTP, looked at a few examples of SIP invite messages. Let's actually do this ourselves. So this is our first lab. This is RTP in action. So I'm going to use our Fusion PBX. I'm going to create an extension because I already created a domain. I want to register that extension, call that extension. The voicemail will pick up and generate RTP stream, and then we'll look at it using a tool called SN grep. So let's go ahead and let's do it. So let's first go to Fusion here, and I'm in my domain already. Let me just make sure I'm still logged in. Looks like I am. For giggles, I'm just going to create another extension, 4,000, save it. Fusion PBX is awesome. It automatically creates a password for me. I'm then going to stick that password inside of a Zorpier phone here. So let me pull my Zorpier phone up. And let's go and grab it. Counts. That little thing here. I'm going to change it to 4,000. And the password, I'm going to unregister and then register. Awesome. So what you're seeing here is the domain, dogfood.dcrouter.net, and then you have a username and then the password that we just was generated for us. And then you're going to see this little funny thing here called use outbound proxy. The reason why we use outbound proxy is because dogfood.dcrouter.net doesn't exist. So you're really proxying that request over to Fusion PBX, where it will actually handle the authentication for that domain. Okay. All right, so that's set up. Now we're ready to place a call, but in order to do that, I want to look at our terminal. I'm going to set that up for we can, and using a tool called SN grep. I want to be able to um, use that. So SNGrep minus C, set it up. I'm going to place a call to that extension, and we're going to see what happens. All right, so this is the call that we care about. I want to hang up on it because we don't need it anymore. So, but let's look at it here. So here goes our SIP invite, and you'll notice the M audio line here, right? So it has the port number, it has the protocol it wants to use, and then here goes all of the codecs. So let's just pick 106. So look at our RTP map, it's 106, it's mapped to Opus, right? And then it actually has some format parameters for that particular codec, right? So, and these are the parameters for that particular codec. And likewise, right? So this is just a quick example of the actual the SIP invite. Let's go down to the 200 OK, and you can see what was sent back from the Fusion PBX server. It's like out of the list of ones that the codecs it has, it came back with 9 and 101. And also you can see that the port number that is advertising is 17,294. All right, so this was a quick example of what it looks like in action of RTP. I appreciate you listening to this particular section. If you're interested in the complete RTP engine course, please see the link below. Thank you.